sklearnensembleExtraTreesClassifier. Description: ExtraTreesClassifier is a powerful ensemble learning method that leverages multiple decision trees to make predictions. It builds upon the random forest algorithm, introducing additional randomness in the feature selection process during the tree construction. This randomness allows ExtraTreesClassifier to be more robust to overfitting and less susceptible to noise in the data. Inputs: X a 2D array-like structure representing the input features, where each row corresponds to a sample and each column represents a feature. Y a 1D array-like structure representing the target values for each sample. Outputs: predictions: an array containing the predicted class labels for new data points. Probabilities: a 2D array containing the probabilities of each sample belonging to each class. Steps: bootstrap aggregating, bagging randomly sample with replacement from the training data to create multiple subsets. Random subspace: randomly select a subset of features for each tree in the ensemble. Decision tree construction: build a decision tree on each subset using the selected features, with the goal of minimizing impurity at each node. Prediction: combine the predictions from all individual trees using a majority vote for classification or averaging for regression. Metrics: accuracy: the proportion of correctly classified samples. Precision: the proportion of correctly predicted positive samples out of all samples predicted as positive. Recall: the proportion of correctly predicted positive samples out of all actual positive samples. F1 score: a harmonic mean of precision and recall. AUC: area under the curve, a measure of the classifier's ability to distinguish between classes. Visualization plots: feature importance plot visualizes the relative importance of each feature in the decision-making process. Decision tree visualization plots the structure of individual decision trees in the ensemble. ROC curve plots the true positive rate against the false positive rate for different thresholds. Fine-tune parameters: nestimators: the number of trees in the ensemble. Max depth: the maximum depth of each individual tree. Minsamples: split: the minimum number of samples required to split an internal node. Minsamples leaf: the minimum number of samples required to be at a leaf node. Max features: the number of features to consider when looking for the best split. Uncertainty methods: bagging: the variance in predictions across multiple trees can be used as a measure of uncertainty. Out-of-bag OOB error: the error on samples not used in the training of a given tree provides an estimate of the model's generalization error. Confidence scores for classification problems: the probability assigned to each class can be interpreted as a measure of confidence. Challenges and fixes: challenge 1: overfitting: if the number of trees or the depth of the trees is too large, the model may overfit the training data and perform poorly on unseen data. Sample use case that resulted in challenge 1: using a very large number of trees with a high max depth on a small dataset. Fixes to challenge 1: reduce the number of trees nestimators or the maximum depth max depth. Use regularization techniques like pruning or early stopping to prevent overfitting. Use cross-validation to evaluate the model's performance on unseen data and tune parameters accordingly. Challenge 2: high variance due to the random nature of feature selection. The predictions of individual trees can vary significantly, leading to high variance in the ensemble's predictions. Sample use case that resulted in challenge 2: using a very small number of features max features or a small number of trees nestimators. Fixes to challenge 2: increase the number of trees nestimators to reduce the impact of individual tree variance. Increase the number of features max features to improve the diversity of the trees in the ensemble. Use bootstrap aggregating bagging to create multiple subsets of the training data and train trees on each subset, further reducing variance.